Hello everyone, in this video, I'm going to teach you how to find the solution set of this given quadratic inequality. We have 6x squared plus 11x minus 10 greater than 0. Finding the solution set of this given quadratic inequality means that we need to find the intervals of x that will satisfy this inequality. And when we say intervals of x, we need to know our boundary points. What are those boundary points? Those boundary points are actually the x-intercepts of the quadratic function y equals 6x squared plus 11x minus 10. And how do we solve for x-intercepts? We set y to 0 because x-intercepts are on the x-axis, and any point on the x-axis has y-coordinate that's equal to 0. That's why we substitute 0 into the y. Let's replace y to 0 and let's solve for x. This time, we're solving quadratic equation. Let's switch the two sides. We can switch the two sides without changing the sign of each of the three terms because of the symmetry property of equality. We have 6x squared plus 11x minus 10 equals 0. How do we solve a quadratic equation? We have four options: square root method, factoring method, completing the square method, or using the quadratic formula. Notice that the left side of the equation is factorable, so I'm going to use factoring method to solve for x. And I will use the AC method or factoring by grouping method to factorize the quadratic trinomial. Let's define ABC. A is the leading coefficient. A is equal to 6. B is the middle coefficient. It's equal to positive 11. C is the constant term. It's equal to negative 10. AC, the product of A and C, is equal to 6 times negative 10. And 6 times negative 10 is equal to negative 60. Then think of factors of negative 60 that will give you a sum that's the same as your B. It's positive 11. What factors of negative 60 will add up to positive 11? We have positive 15 and negative 4. Let's double check. 15 times negative 4 equals negative 60. 15 plus negative 4 equals positive 11. Then we split 11x into two terms. We now have a 4-term polynomial, 6x squared plus 15x minus 4x minus 10 equals 0. These are similar terms. If we combine them, it's equal to 11x. Next, we group the terms. We group first and second terms. We group third and fourth terms. 6x squared plus 15x grouped together. Then we also group the third and fourth terms. Notice that the preceding sign of 4x is negative. It's also the sign in between our two groups. Be careful if this is a minus sign. Make sure that if we distribute the negative into each of the term inside the second group, the results will be negative 4x and negative 10. So this should be positive. Let's double check. Negative times 4x is negative 4x. Negative times positive 10 is equal to negative 10. Next, factorize each group using the GCF method. So for the first group, we factor out their GCF. The GCF of 6x squared and 15x is 3x. Divide each term of the first group by their GCF. 6x squared divided by 3x is equal to 2x. 15x divided by 3x is equal to 5. Let's also factorize the second group. Factor out their GCF. The GCF of 4x and 10 is 2. Factor it out. Divide each term of the second group by their GCF. 4x divided by 2 equals 2x. 10 divided by 2 equals 5. This is our desired result. There should be a common binomial factor in our succeeding step. Because what we want to do is to factor out the common binomial factor. So let's factor it out. If we factor this out, left over will be 3x. If we factor this out, left over will be negative 2, equal to 0. These are the factors of 6x squared plus 11x minus 10. Let's double check before we proceed. Let's FOIL the factors. 2x times 3x, first term times first term equals 6x squared. Outer times outer, negative 4x. Inner times inner, positive 15x. Add negative 4x, positive 15x equals 11x. L, last times last, 5 times negative 2, negative 10. Therefore, we have the correct factored form. Next, we use the zero product property. We set each factor to 0 and solve for x. The first factor is 2x plus 5 equated to 0. Transpose 5 to the other side. Don't forget to change the sign. We're left with 2x on the left. Then isolate x by dividing both sides by 2. 2x divided by 2 equals negative 5 divided by 2. X equals negative 5 over 2. This is our first x-intercept and also our boundary point. Let's solve for the other x-intercept by setting the second factor to 0. We have 3x minus 2 equal to 0 and solve for x. Transpose negative 2 to the other side, it becomes positive. On the right, we're left with 3x on the left. Then we isolate the x, divide both sides by 3. We have 3x over 3 equals 2 over 3. Cancel 3, x equals 2/3. We have another x-intercept, and this is also a boundary point. Okay, so we're now ready to plot our boundary points into the number line. Let's draw our x line. And let's plot our boundary points or the x-intercepts. Make sure when you plot, they are in order. Smaller value on the left side, larger value on the right side. Which is smaller, it's negative 5/2. 2/3 should be placed on the other side, on the right side. Okay, so as you can see, the number line is divided into 3 regions. We have the leftmost region, all the numbers to the left of negative 5/2. This is our first boundary point. Then we have the middle region, all the numbers between negative 5/2 and 2/3. And the rightmost region, all the numbers to the right of 2/3. Let's put negative infinity, positive infinity. Let's write down our intervals. So for the leftmost region, we represent all the numbers as x less than negative 5/2. In terms of interval notation, we can express all the numbers to the left of negative 5 halves as negative 5 halves to negative infinity. Represent all the numbers between the two boundary points as x greater than negative 5 halves but less than 2/3. In interval notation, negative 5 halves, comma, 2/3, and close with parentheses. Then all the numbers to the right of 2/3 can be represented by x greater than 2/3. By interval notation, it can be written as 2/3 positive infinity. Okay? Now, we're going to set up our table of signs. In the first column, we will just write down the factors of the quadratic trinomial. The first factor is 2x plus 5. The second factor is 3x minus 2. 2x plus 5, 3x minus 2. That if you multiply them together, it's equal to the original quadratic trinomial on the left side of our statement. We have 6x squared plus 11x minus 10. In the first row, we will write the three intervals. You can use the inequality notation or the interval notation. Let's use the inequality notation. We have x is less than negative 5 halves. Then x greater than negative 5 halves but less than 2/3. Next, we have x greater than 2/3. For each interval, you choose one test number. You can choose any number as long as it falls under the interval. So our first interval is x less than negative 5 halves. Think of any number that's less than negative 2 1/2. I'll choose negative 3. Negative 3 is less than negative 2 1/2. For the second interval, x greater than negative 5 halves but less than 2/3, I can choose 0 as my test number. 0 satisfies this interval. And for the last interval, x is greater than 2/3, I can test 1. 1 is greater than 2/3. Okay? Then, you plug the test values into each of the factor and determine the sign of the result. Let's test negative 3, substitute into the first factor. If x is negative 3, 2 times negative 3 is negative 6, plus 5, negative 6 plus 5 is negative 1. The result is negative. If x is negative 3, substitute into the second factor. 3 times negative 3 is negative 9. Negative 9 minus 2 is negative 11. The result is negative. If you multiply the factors, it's equal to this product. So if you multiply two negative numbers, the product is positive. Next, let's test 0. If x is 0, 2 times 0 is 0 plus 5, positive. If x is 0, 3 times 0 is 0 minus 2, it's negative. Multiplying a positive number and a negative number will give you a product that's negative. Next, let's test 1. If x is 1, 2 times 1 is 2 plus 5, positive. If x is 1, 3 times 1, 3 minus 2, positive 1. If you multiply two positive numbers, the result is positive. Okay? Let's go back to our given quadratic inequality. 6x squared plus 11x minus 10 is greater than 0. Which of the three intervals will make this statement true? We have greater than 0. The inequality statement is always true if the numerical value at the left side is any positive number. any positive number greater than 0, it's always true. So referring to our table of signs, we are looking for intervals that will give us a positive result for the left side. This is positive. This is also positive. The corresponding interval of x for this is x is less than negative 5/2, and the corresponding interval for this is x is greater than 2/3. Therefore, the solution set of this given quadratic inequality is x is less than negative 5/2 or x is greater than 2/3. This is in inequality notation. Expressing the solution set in interval notation, x is less than negative 5/2 is the same as negative infinity, comma, negative 5/2. This is 2/3, infinity. Replace or with the symbol for union. It looks like capital U. This is in interval notation. Note that if the boundary point is not included in the solution set, use parentheses. That's why this is parenthesis, this is also parenthesis, because the boundary points negative 5/2 and 2/3 are not in the solution set. They won't satisfy the given inequality. And always remember that parenthesis always comes with the negative infinity and the positive infinity. You can also express your solution set using set builder notation. You just use braces. The set of all x such that at the right of your vertical bar, just copy the inequality notation. This is the property of each of the element in the solution set. X is less than negative 5/2 or x is greater than 2/3. This is expressed in set builder notation. Okay, so we have our solution set expressed in 3 different notations. We have the inequality notation, the interval notation, and the set builder notation. If you have any questions or you want further clarification, leave a comment. Please don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.